Okay, I'll turn this way so you can see me. Welcome. This is Math 095, and I am going to be working with you to show you how to do everything. And this is a rather clever little thing. You just watch and listen, and I will be writing on this whiteboard. Let me show you. So this is Math 095. It's not the best writing in the world, but you'll get used to it, okay? So we are going to start with 1.1. I'm going to go over 1.1 through 1.4 today. So you can stop this, go work on your problems, come back, you can stop, start, you can re-look at it over and over and over again. This is for you. This is your personal, let me help you get through this course. Okay, and I'm going to have these videos for each section. Today I'm going to do all 4 sections, 1.1 through 1.4. Well, we'll see. I'll see how far I get. If I get interrupted and I have to stop and come back, and that's what I'll do. But I'm going to try to see what I can get through. Okay, so let me get my notes here, and let's get started. Wait a minute, one more page. Okay. Now, this whole first chapter is establishing some things that you need to know, that you should already know, and I'm going to re-teach you or remind you, that kind of thing. But a lot of it has to do with vocabulary. So I want you to listen very carefully and see what I'm writing down, okay? Hang on one second. This is Elizabeth. I need to call you back, okay? Hello? Can you hear me? Yeah, you're breaking up anyway. I need to call you back in about 20 minutes. Okay, bye. All right, sorry about that. All right, so looking at 1.1, we start out with what we call sets. And sets are just a collection of objects. That's all they are. Okay? Now, once we have the objects are called the elements. Those are the objects in a set. Okay? And a set looks like this. It could be like 1, 2, 3, 4. Okay? So these lines right here represent the fact that it's a set, and these are the objects. So 1 is an object, 2 is an object, 3 is an object, etc., etc. Okay? Now, there are very specific sets we can look at. If you see the capital number N, that has to do with the set of what we call natural numbers. Now, natural numbers are whole numbers starting with 1 and going on forever. That dot, dot, dot means going on forever, okay? Or you can have a capital W. Now, that stands for whole numbers. The difference between natural and whole numbers, look what I'm writing. What's the difference? Just the 0. Whole numbers include 0. Now we can have I, which are integers, and look at what that adds. -2, -1, 0, 1, 2. Okay, so what the difference between integers and natural and whole is, okay, I still have my 0, my 1, my 2 going on, but now I add the negatives. But notice they're whole. They're not a fraction or a decimal. Okay, then we get into rational numbers. And rational numbers, those are numbers that can be written as a ratio, or what you better know. What's the other word for ratio? Fraction, as a fraction, okay? Anything else are what we call irrational numbers. Irrational numbers can't be written as a ratio or a fraction because they are non-terminating, non-repeating, decimal numbers. So, for instance, pi, that looks like a paragraph sign. Pi, that's 3.1415, blah, 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 blah. It goes on forever, it doesn't stop, and it doesn't repeat. That's why it's called an irrational number. If I had 0.363636, that goes on forever, but it repeats. So I know what it is, so it's irrational. Irrational are only if it doesn't stop and it doesn't repeat, okay? All right, now, we also have this symbol, and that means is an element of. So I could say let's say this is my set, 1, 2, and 3. I could say 2 is an element of that set. I could also say 5 is not an element of that set. Okay? So this symbol right here just means is an element of. Okay? Then we go into what we call set builder notation. Okay? Set builder notation. It's just another way to write a set. This way right here, which you're used to looking at, that's called a roster. It's called roster method. It's just listing the sets, the elements in the set, blah, 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 blah. Set builder notation is more describing the set. So for instance, this set right here in set builder notation would look like this. I'm describing it. The set, you have to have that, and then you have to have these two pieces, x such that, and then you describe what x is. X represents all these things. So x is a natural number less than 4. Would that be 1, 2, and 3? Yes. So listing the numbers, describing the numbers. Listing the elements, describing the elements. Okay? So, for instance, let's look at this. What if I had x such that x is one of the first 5 even natural numbers? Could we list that in roster form? One of the first 5 even natural numbers would be 2, 4, 6, 8, and 10. Set builder notation, roster. Okay, let's see if we can go the other way. What if I give you one in a roster form? Hang on, I got to get a new board. Hang on just a second. Go back up to the top. No. Oh, there it is. Turn, new whiteboard, and go back. Okay, move this over. What if I had, here is my set. 1, 3, 5, 7, 9, going on forever. How could I rewrite that in set builder notation? Well, do this, do this, do this. Now let's describe x. X is an odd natural number. 1, 3, 5, 7, 9, 11, blah, blah, blah. So listing the elements, describing the elements. Roster form, set builder notation form. Okay? All right. Another thing that they talk about in this 1.1 is what they call the additive inverse. The additive inverse is just the negative sign. Okay? But let's look at it. The additive inverse, or the negative sign, or the opposite of. So if I had the number 4, its additive inverse would be -4. The opposite. If I had the number -6, its additive inverse would be 6. All you're doing is adding the negative. Now let's think about it here. If I started out with -6 and I added a negative, 2 negatives make a positive, which is what we got here. Don't let it confuse you. Additive inverse. -4, the additive inverse is 4. +5, the additive inverse is -5. -8, the additive inverse is 8. +10, the additive inverse is -10. It's just the opposite of. Okay? All right. Now with that said, what about absolute value? Absolute value are these straight lines. Okay? Absolute value is the distance from the given number to 0 on a number line. That's the actual definition. So if I said, what's the absolute value of 3? What I'm saying is, here's 0, here's 3. 1, 2, 3. Its distance from 0 is 3. What's the absolute value of -3? Well, it's still 1, 2, 3. +3. It's a distance, so it's always going to be a positive answer. Always. Okay? So if I had the absolute value of -5, my answer would be 5. If I had the absolute value of -10, my answer would be 10. If I had the absolute value of +10, my answer would be 10. If I had the absolute value of +8, my answer would be 8. Only time it gets tricky. What if I said the additive inverse of the absolute value of 3? What is the absolute value of 3? 3. And what's the additive inverse of 3? -3. The only time it would become out a negative because the negative is on the outside. What's the additive inverse of the absolute value of -3? Now think about it. What's the absolute value of -3? 3. What does this ask for? The opposite of that, which is -3. So be very careful if there's a negative on the outside. That's the only thing that's going to make it different. Okay? All right. Now, let's also look at these signs. Okay? Less than or greater than or equal to. Less than, greater than, less than or equal to, greater than or equal to. Okay? The straight line on the bottom just means or equal to. So if I said x was greater than 5, I'm saying it's any number greater than 5. If I say x is greater than or equal to 5, now I'm saying it can be 5 or anything greater. But just saying it isn't what we want. We want to be able to graph it. Okay? So here's 0 and here's 5. Now, the old way was, if it was like this, try to remember this. If it's greater than 5 but not equal to, you'd put an open circle and you shade in this way. And if it was greater than or equal to, then you'd put a closed circle and you'd shade. Well, instead of open circles and closed circles, we use something different now. We use parentheses or brackets. Parentheses are in place of open circles. Brackets are in place of closed circles. And then, of course, if it was going the other way, the parenthesis would go that way. If it was going the other way, the bracket would go that way. Okay? All right. Let's now keep that in mind. Let me get a new whiteboard and let's try something, okay? All right. Let's say I wanted you to graph, and it looked like this. X such that x is greater than -2. Okay. Here's 0. Here's -2. Now, x is greater than, so it's going to be going this way. X is not equal to, so it's just a parenthesis, and then you shade in that way. Okay? All right, let's try another one. What if I had x such that x is less than or equal to 4? Okay, well, here's 4, here's 0. Now, it's less than, so it's going to be going this way, and it's or equal to, so it gets a bracket. And then it's everything shaded this way. Okay? All right. Let me show you, let me throw something in here. What if I had x such that x is greater than 3, but it's less than 10? All right, we can do that. Here's 0, here's 3, here's 10. Now, let's put this together. First of all, x is greater than 3, but not equal to, so it gets a bracket. It's going this way. When we get to 10, x is less than or equal to 10, so it gets a bracket. It's going this way. So it's everything in between, bracket and parentheses. Now, what we need to know from all of this is something called interval notation. We can graph it all, but we have to go one step further and write it in interval notation. Let's look at this first. What is the farthest thing to the left on this graph? -2. Okay, if that's the number, that's where it stops. What is the farthest thing to the right on this graph? Well, it goes on forever, so it's called infinity. Now, -2 has a parenthesis, and infinity goes on forever. The rule is with infinities, always parentheses. With infinities, always parentheses. This right here is interval notation. What it says is not including 2, but everything from -2 to infinity. All right, let's try to do this one. What's the farthest thing to the left? It's going on forever, but what infinity is it? It's -infinity. What's the farthest thing to the right? 4. What did I tell you infinities always get? Parentheses. What does 4 already have? A bracket. There's interval notation for that answer. All right, let's try to do this one. Let's do this one. What's the farthest thing to the right? 3. To the left. What's the farthest thing to the right? 10. What does 3 have? Parentheses. What does 10 have? Bracket. Interval notation. All right, let's try to do one more. Let's do one more, the whole thing through. Okay? So if I had x such that, let's say -2 greater than or equal to, but less than 5. All right, here's -2, here's +5, 0 somewhere in there. All right, let's graph. First, we're going to graph this. X is greater than or equal to -2, so it's a bracket going this way. But when we get to 5, x is less than 5, so it's a parenthesis, and it's going this way. So it's everything in between. Now, how would I write this in interval notation? Farthest thing to the left, -2. Farthest thing to the right, 5. -2 has a bracket, 5 has a parenthesis, interval notation. Okay? Now that's a lot. That is all. Make sure I hit everything in 1.1. Yep, that's all 1.1. Okay, and I am going to stop now, and I'm going to record 1.2 separately. So, if you have any questions, you can email me, and then I can do this, answer your questions, and send this to you. Look for, you need to continually look for these, the addresses for this. I will put them in Blackboard. I'll put them in Blackboard each week. Okay? All right. See you in a little bit.